The topic of this video is represent and compare whole numbers up to 1 billion, and this here is the grade 7 topic that we're going to be focusing on, and this here is going to be addressing the expectations here, which is the following. First is to represent whole numbers up to 1 billion, and this here is a keyword which is whole numbers, and the next keyword here is using the following, which is expanded form with powers of 10. And the next expectations is to understand how these numbers are used in our lives. Now, first, for minds and activity, the question here is, when do you encounter small numbers versus when do you encounter large numbers? You can list a couple of examples below here, and as well as examples below over here. Now, once you've listed them out, let's check our results together. Now, some examples of small numbers is when you're dealing with microscopic objects, and this here is really handy in terms of researching biomes that are at the microscopic level. Next is looking at when you're dealing with, in this case, atomic level subjects or objects. And so these here are some of the great examples of when we approach small numbers, while on the other hand, when it comes to large numbers, we deal with things like, for example, population in a city, either humans or species. When we look at distances, that is, let's say, from one city to another, and when we deal with budgeting, like, for example, dealing with huge amounts of money transfer in terms of countries, or many more things in here. Now, at the grade 7 level, we'll be focusing mainly on this subject area which deals with larger numbers, and this here focuses on numbers that are greater than 1. Now, looking at expanded form with powers of 10. Powers of 10 involves systems that involves when we have, for example, 1. This here in terms of powers of 10 is 10 to the power of 0. And next is when we deal with the number 10, and you show this in terms of multiplying it by 1. This is the same thing as saying 10 to the power of 1. And next is how about 100, which means that you're multiplying 10 by 10, and this here implies that you have the power of 2, which means you have 2 tens, and you're multiplying them together, and you see what is going on, that as I add zeros after 1 in the left side, we have this to represent the power that is above the 10 as the base. And you see that if we have 3 zeros after 1, which means that we are going to have a 3 that is the exponent, and the base is our 10, and so on and so forth. So the challenge is, how about this one here, which I want you to try? And this here shows that once you pause and now you play the video to check the result, this here is the same thing as multiplying 10 by 10 by 10 by 10 and by 10, and finally one more 10, which means we have how many tens here? 6 tens that you're multiplying together to give you a million. And this here means that since we have 1, 2, 3, 4, 5, 6 zeros, it means that our exponent is 6 and our base is 10. And so this here is million. And how about you pausing this video after trying this question here, which is this number, which is how many zeros here, without you showing this expanded form by multiplying this repeating tens in here. And now replaying this video, what we do is we just get our base to be, in this case, 10, and our exponent is how many zeros after our 1. We have, in this case here, once we count now the number of zeros, we have 3, we have 6, we have 9, and so that means our exponent of our 10 is 9. And so this here is our form, that is the power of 10 that represents this, which is called a billion.